To do arithmetic using the expanded notation, we just think about what everything means. For example, if we want to add 148 to 263, that means one times 10 to the second plus 4 times 10 to the first plus 8 times 10 to the 0 added to 2 times 10 to the second plus 6 times 10 to the first plus 3 times 10 to the 0. The result that we get is going to be, well, 8 and 3 is 11, so we have 11 times 10 to the 0. 4 and 6 is 10, so we have 10 times 10 to the 1. And 1 and 2 is 3, so this is how many 10 to the seconds we have. 1 10 to the second and 2 10 to the seconds makes 3 10 to the seconds. Of course, we can't write this number back in the original notation. We can't write 3, 10, 11. That would have 31011. It would be 31,011. We don't want to write the number quite that way. What we do is we say, well, 11 times 10 to the 0 is 10 times 10 to the 0 plus 1 times 10 to the 0. So this is and of course 10 times 10 to the 0 is 10. Well, we could say 10 to the 1. So this is a 10 to the 1 plus 1 times 10 to the 0. And our 10 times 10 to the 1, that's 10 times 10 to the 1 equals 10 to the second. So what we have is 3 times 10 to the second and another 10 to the second, leaving us no 10 to the first here at the time being, but then we have a 10 to the first from here and a 10 to the 0. So that putting this 10 to the second together with these 3, we get 4 times 10 to the second. Now that leaves us no 10 to the seconds here, but or 10 to the first here, but we got one from here, so we have 1 times 10 to the first, and then plus 1 times 10 to the 0, which now translates back into our sum, which in this case would be 411. And of course, if you do the addition by the usual algorithm, you really do the same thing. 8 and 3 is 11, just like the 11 times 10 to the first, which we broke down, or 10, I'm sorry, 8 and 1 is 11, meaning 11 times 10 to the 0, which we did over here. And remember, we regrouped this into a 10 to the 1 plus 1 times 10 to the 0. What do we do with the usual algorithm? Well, we put a 1 up here. We carry the 1. And when we add then the 1 and the 4 and the 6, we end up with 11. And we carry another 1, and we add these up, and we end up with 411. Now this is just analogous. This represents what we've really done over here. What we've got over here represents what we're really doing when we do this. When we write these 1s and carry them and all that stuff, we're just regrouping 11 10 to the 0s into a 10 to the 1 plus 1 10 to the 0. Now let's zoom in just a little bit so we can see some details that we might have missed here. So the 11 times 10 to the 0 groups into 10 times 10 to the 0 plus a 1 times 10 to the 0, 10 to the 1 plus 1 times 10 to the 0. 10 to the 1 will, of course, go over into this place. The 10 times 10 to the 1 that we have right here, it becomes a 10 to the 2, which gets added to the 3 10 to the 2s, giving us 4. 10 to the 1 that we end up with here, of of course, will be represented over here in the 10 to the 1's place, and the 1 10 to the 0 that we have left is over here. Now, using similar reasoning, we can subtract 179 from 284. Yeah, let's zoom back a little again. Okay, the meaning of 284 minus 179 is 2 times 10 to the second plus 8 times 10 to the first plus 4 times 10 to the 0. And we're subtracting 1 times 10 to the second plus 7 times 10 to the first plus 9 times 10 to the 0. Now we're going to have a hard time doing that, similar to the hard time we had with some of the subtraction problems using the Egyptian method, because the 9 won't subtract from 4. You can't take 9 out of 4. So what we're going to have to do is we're going to have to take one of these 10 to the 1's over here and make it into 10 10 to the 0's. So we rewrite as 2 times 10 to the second plus only 7 times 10 to the first, and then that's going to give us 10 10 to the 0's to add to the 4 that we have, and we're going to have 14 10 to the 0's, from which we'll subtract a 10 to the second and a 7 times 10 to the first and a 9 times 10 to the 0. And now we can do everything. 14 minus 9 is 5, so we have 5 10 to the 0's here. We have no 10 to the 1's, and we have 1 10 to the second, which translates back into the number 105. If we use the usual algorithm to do the subtraction up here, of course, what do? We take the 8 and we replace it by a 7, and we carry a 1 over here. So we think of this as 14 minus 9, which is 5, 7 minus 7 is 0, 2 minus 1 is 1. And again, that's a simple representation of what we did over here.